Water is something we use every day. To learn more about water, let's observe some simple demonstrations that show what water does. I've filled this glass right up to the brim. What will happen if I add more water? As I add water slowly with this syringe, watch the water in the glass. It bulges over the top. The surface of the water acts as a kind of film, holding the water in the glass. We say, water has surface tension. We can test the surface tension of water using this needle. I'll put it into this wire holder and lower it to the surface very carefully. The needle is held up by the surface tension. Scientists know that surface tension is caused by the molecules of water attracting each other. If we break the surface film, the needle sinks. So we've seen something about the surface of water. Now let's experiment with water below the surface. This glass tube has a sheet of rubber across one end. Watch what happens when I push the tube underneath the water. The rubber sheet is pushed up into the tube by the water pressing against it. Water exerts pressure. Let's see more about water pressure. Here are two cylinders filled with water. This one has holes around the bottom covered with tape. I'll remove the tape. The water is pushed out by the water pressure inside the container. The water is being pushed out about the same distance, so the pressure must be the same at each hole. This one has holes from top to bottom. I'll remove the tape, and now at the top hole the water is pushed out the shortest distance. The farther down a hole is, the farther the water is pushed out. The deeper the water, the greater the pressure. Here's another way to see that the deeper the water, the greater the pressure. I'll use this glass tube again. As I push it down slowly, watch the sheet of rubber at the end. The deeper it goes, the more it is pushed in by the pressure. What will happen if I pour water into the tube? I'll use this colored water so we can see it clearly. The water inside the tube exerts pressure too, pushing the rubber sheet down. When the water is the same level inside the tube as outside, the rubber sheet is flat. So, water pressure pushes down as well as up. Does it push in every direction? Let's see. I'll use this pressure gauge. Whenever anything, such as my hand, presses against the end of this tube, the needle on the gauge shows the change in pressure. Notice that the pressure is increasing as I lower the tube into the water. Now I'll keep the end of the tube at the depth marked by this line. No matter which way I turn the end of the tube, as long as I keep it at the same depth, the pressure is the same. So, Water exerts equal pressure in all directions. What effect does this pressure have on something in the water? Here are 3 blocks. This one floats high in the water. This block does not float as high. This block sinks. Why do some objects float and others sink? When I push down on this block, I can feel a force pushing up on it. We call this upward force of water buoyancy. Water can produce a buoyant force. When I place this cube in the water, it sinks. Does buoyancy have any effect on this cube even though it doesn't float? We'll find out with this scale. I'll weigh the cube and mark the weight with this arrow. Now watch the scale as I place the cube in the water. The cube weighs less in water than it did in air. While the cube does not float, the buoyant force of water still acts on it. Is every object buoyed up by the same amount of buoyant force? This balance. And these metal cylinders will help us find out. Watch the water level rise as I lower the cylinder into the water. Any object in water pushes aside or displaces some of the water. This larger cylinder displaces much more water. Although the cylinders are different sizes, the larger cylinder is made of a lighter metal, and they weigh the same. They balance each other. Now I'll place the balance so the cylinders are in the water. In water, the larger cylinder weighs less than the smaller one. Remember, the larger cylinder displaces more water. The more water an object displaces, the greater the buoyant force acting on it. Let's measure the buoyant force acting on this plastic box. With this scale, we can measure the force in pounds. As I push it down, the box displaces more water and the buoyant force increases. Now the box is being buoyed up with a force of 2 pounds. How much water does the box displace for 2 pounds of upward force? I'll mark the water level on the side of the box. Now I'll let just that amount of water into the box. I'll weigh the water with this scale. It's set so it won't weigh the container, but only what's in the container. The water weighs 2 pounds. This is the same amount as the buoyant force when the box displaced this much water. So, the buoyant force acting on an object is equal to the weight of water the object displaces. Let's see how the buoyant force affects the 3 blocks we saw earlier. One is very light, one is a little heavier, and one is very heavy. This block is so light that it displaces very little water, a small amount equal to the small buoyant force that keeps it afloat. This block weighs about the same as all the water it can displace. Will it sink or float? It barely floats. Its weight is just about equal to the buoyant force acting on it. This block weighs more than all the water it can displace. Will it sink or float? It sinks. So an object floats when it displaces enough water to equal its own weight. When it weighs more than the most water it can displace, it sinks. This boat floats. The water it is displacing is equal to the weight of the boat. Now I'll add more weight to the boat. As the weight increases, the boat sinks lower in the water. Now the boat has sunk very low in the water. What will happen when the boat becomes heavier than all the water it can displace? It sinks. The boat is made so it can be enlarged. I'll keep the same weights in the boat, but make it bigger. Now it can displace more water than it did before. The boat floats easily with all the weights in it. It is displacing more water now, so the buoyant force acting on it is greater. We've seen three important things about water. We saw that water has surface tension. Water exerts pressure. And water can produce a buoyant force. These three basic principles will help us as we learn more about water and the way it behaves.